My name is Cameron Hayes. I'm a professional, semi-pro morale booster, and part-time dirtbag. I've been in the Army since 2007. For about the past 6 years, I've been an instructor for the Army. I teach everything from map reading and radios to marksmanship and machine gun emplacement. So I teach a little bit of everything. I'm also an instructor on the civilian side. I'm a partner and instructor for DEFCON Delta Tactical out of Kings Mountain, North Carolina. I'm a competitive shooter, and I shoot IDPA, USPSA, PRS, 3-gun, so I compete. I have my degree in criminal justice, latent evidence, and Pew is life. Yeah, so I got a lot of shooter math going on up here, and that is the content of this video, is shooter math. First things first, I want to throw a shout out to Miss King. Apparently she saw my video about these DMR dope cards by Red Hill Tactical, and she saw the math involved in it and thought it would be cool to show to her kids. Apparently she's a teacher, and the only problem was my language. And I've said it before, I'll say it again. I'm not the kind of guy that you take to meet your parents. I'm the kind of guy that you bring to a gunfight with you. I'm going to work on it for this video just so that it can be presented to students so that they can see that math can be used in the military for shooting, for recreational things, and it can be fun because missing your target's not fun, believe me. So I'm going to try to keep this video G-rated or gangsta rated. You know what I'm saying? I instantly hate myself for doing that. What does that even mean? It's like, can I pick stuff up with it? Shooter math, sniper math, ballistics, call it whatever you want. Whenever you're shooting a target, you're using some kind of math. Regardless of if you realize it or not. And that goes from the recreational shooter to the professional body stacker. And there are elements of math, science, and as a branch of science, physics and chemistry. It's all involved. There are a lot of things that affect what's going on whenever your bullet's traveling through the air. Where the heck did that come from? Alright, it's time for this video to get a little bit more cereal. I actually don't have any cereal because for breakfast I usually have coffee and hate. Coffee and hate. That's what really keeps me going. So let me try to explain what an angular unit of measure is. An angular unit of measure is a constant that can be, the farther away it is, it constantly grows the same way. It's not exponential. So what does that look like for a shooter? We use minutes of angle, but we're not going to go into that yet. I'm going to go into that here in a minute. But let's just say that whenever you shoot at a target, you shoot a 1-inch group at 100 yards. Well, what does that really mean? It means that your rifle ammunition shooter combination can achieve a 1-inch group at 100 yards. So theoretically, using angular units of measure, that 1-inch group at 100 yards being an angular unit of measure and it's a connular, you should have a 2-inch group at 200 yards, a 3-inch group at 300 yards, a 4-inch group at 400 yards, and a 5-inch group at 500 yards. Well, let's say that we change that number to 2. Well, that's simple still. You just multiply it by how many yards away it is, or by the unit of measure multiplied. So you have 100 yards, a 2-inch, so it would be 4 inches at 200 yards, 6 inches at 300 yards, 8 inches at 400 yards, etc. So it looks like this, 1, 2, 3, 4, 5, and it just, it's constant growth. First of all, I want to start off by saying that it was a big pain in the tushy getting this thing to where the light wasn't reflecting off of it so that y'all could actually see my wonderful artwork back here. Look at this. I took time on this. I used a permanent marker and it took me a really long time to erase. Oh, I'm dumb. Anyway, all right, so we're going to talk about MRADs, or mil radians. So what is an MRAD? Let's start off with a radian. A radian is an angle where the arch is equal to the length of the radius, which equals out to be 57.296 degrees. A milli is a thousandth of that. So 1,000th of a radian is where this angular unit of measure comes from. So what does that equal out to? Well, it's always 1/1000th of whatever the final unit of measure is. So at 1,000 meters, your size is 1 meter. At 1,000 yards, your size is 1 yard, or 36 inches. Knowing this, then you can just take off one of those zeros and say at 100 yards it's 3.6 by moving the decimal place over. So let me see if you guys can actually see that. See if I can clear that picture up for you. Oh, yes. Yes. Got it. All right. So why is this applicable? Well, because I think just about everybody's seen one of these before. It's a reticle. Some of y'all Call of Duty players and junk. I play Call of Duty too. So this is what the back side of a rifle looks like. You're looking through your scope, and you've got your turrets on the top and on the side for elevation, windage, and then you've got your parallax adjustment, and then you've got your mils. So you can use what you know about the angular unit of measure to figure out how far away a target is, or if you already know how far away it is, how big something is. So we're going to talk about that real quick. For reference, a man is roughly from one edge of the shoulder to the other 18 inches wide, and from the crotch to the top of the head, they're roughly 36 inches. And as you all know, because of basic math, half of 36 is 18, so that helps even more with your numbers. So what can we do with this information? What can we do knowing that someone is roughly 18 inches across, 36 inches from the crotch to the top of the head? Well, knowing what we know about mil radians, I know that if someone from the crotch to the top of their head, it fills up 1 mil inside of my scope, I know they're 1,000 yards away. If they fill 2 mils between the crotch to the top of the head, then I know they're 500. 3 is 333. 4 is 250. And I know this from experience. I've done it, so I know that this math is correct. Now let's say that you're milling something that maybe doesn't fall into such a neat and nice category of like 18 inches or 36 inches. If you know how big something is in inches, and you want to know how far away it is in yards, and you have a optic that has the angular unit of measurement mil radian in it, then you take the number that it is in inches, so X inches, you multiply it by 27.7 repeating, or I use 27.778, and you divide it by how many mils that target size takes up inside of your reticle. Okay, so I've got it all written out right here where you can seize it. So you take your target size in inches, you multiply it by 27.7 repeating, as I said before, you divide it by the size of the target in mils, and then you get your distance in yards. And what that looks like is, for example, because I'd already used 36, I figured I would use it for this, 36 times 27.778 divided by 1 mil equals 999.99 yards, so 1,000 yards. So that's just, proof that it works. All right, now let's quickly discuss the flip side of that coin. So let's say that you have an LRF, or the distance, LRF is laser rangefinder, or another way to know the distance to your target, but you don't know how big your target is. Well, that's just basically taking the same equation and jumbling it around until you get the right answer. You're just basically reversing it. So you would take your distance in yards, because you know that. You either lased it or you have known distance to target. You would multiply it by how many mils that target fills up inside of your reticle. You would divide it by 27.7 repeating, and it equals your target size in inches. Yeah, I definitely used a permanent marker on that whiteboard, so not going to be using that anymore. That's why we can't have nice things. Alright, so let's talk for just a second about bullet drop. Bullet drop is 9.8 meters a second per second. So what that looks like is 9.8 meters a second squared, meaning that your bullet drop is exponential. Now, what that also means, knowing what we know about, physics and gravity and stuff like that, is that your bullet weight doesn't actually affect your bullet drop. It's your time in flight. That's what affects your bullet drop. So, distance-wise. So, your weight of your projectile doesn't matter. It's, your ballistic coefficient is going to dictate how effectively and efficiently the bullet flies through the air, and your speed, your muzzle velocity, at the beginning, and then it's going to change over time. So if you have a high BC bullet that's moving really fast, your bullet drop is going to be lesser at a given distance because it takes less time for that bullet to get there. I hope I said that right, because if I messed it up, I don't feel like fixing it. All right, so for example, I have a bullet, a 6.5 Creedmoor projectile that is 140 grains. It moves 2,610 feet per second out of my barrel, and it has a ballistic coefficient of a 0.58. So, given that information, I can tell you that at 300 yards, with a 100-yard zero, my 100-yard zero means that my point of aim and point of impact is met at 100 yards. So, my point of aim and point of impact meet at 100. So then beyond that, your bullet is dropping. But technically, from the time the bullet leaves your muzzle, it's dropping. But you have height overboard from your sights. That's something for another video. Anyway, I know that with what I'm shooting, my bullet drop at 300 is 12.8 inches. 12.8 inches divided by 3, because it's 300 yards, equals, bleh, I'm not doing that in my head, divided by 3.6 equals 1.2. 1.2 mils. So now, instead of going, okay, my bullet's dropping 12.8 inches, what is that? I'm just going to do a holdover. I mean, yeah, that one's not that hard. A foot, we all know what a foot looks like, right? All right, well, let's take 500 yards. At 500 yards, my bullet drops 56 inches. Now, I don't know about you. I don't know how good you are at eyeballing stuff. But 56 inches is getting into a little bit of a gray area where I'm like, might not be able to just eyeball this one. But it's okay. The angular units of measure are here. So you take your 56, you divide it by 5, equals bleh, and then you divide that by 3.6, and that gives you 3.1. So then I know that in order to compensate for that much bullet drop at 500 yards, all I need to do is adjust my turrets 3.1 mils, center hold on target, and pull the trigger whenever you're not factoring in wind and other factors. So 3.1. Something that I mentioned in my last video that caught someone's attention was I was talking about these DMR dope cards by Red Hill Tactical, and I was talking about how it uses hundredths of a mil on this dope card, and what I meant to get but didn't was tenth of a mil. And some people would say, well, don't you want that finer adjustment? And I mean, if you think about angular units of measure the way that I do, every tenth of a mil, which is what my scope adjusts in, every tenth of a mil is 0.36 inches at 100 yards. Multiply that by 10, and at 1,000 yards, every tenth of a mil of adjustment that I make on my scope, the same adjustment that only makes 0.36 inches of adjustment at 100 yards, makes 3.6 inches of adjustment at 1,000 yards. So the question kind of boils down to, do I have a rifle ammunition shooter combination that is capable of precision great enough to utilize something that's finer than a 1/10 mil adjustment? And the answer to that is no. There's nothing in my arsenal that fills a category that fits that bill. So 1/10 of a mil. If I make a 1/10 of a mil adjustment at 1,000 yards, like I said, it's 3.6 inches. So, but it changes for every distance, like I said, an angular unit of measure. And I had told somebody recently that sometimes I don't account for wind because the size of the target is so large that even if my wind hold is a full mil, I would still impact the target. So, for example, at 100 yards, it's 3.6 inches is 1 mil. At 200 yards, it's 7.2. 300, 10.8. At 400, it's 14.4. All right, so we'll just back it down to 300. So at 300, you're just barely outside of that 18 inches widthwise that I was talking about, where you're already starting to go, okay, well, I would miss my target if I didn't account for wind at 300. It goes all the way out to 300 for that. If you had to hold a full mil of wind at 300. I don't know what bullet does that, but maybe a 22 long rifle or something similar. Now, this is my actual dope card, my DMR dope card. At 300 with a 10 mile an hour wind, I have 0.6 mils. So the reason that I chose to use a 10 mile an hour wind on my dope card is because now I can use a decimal. If I don't have a 10 mile an hour wind, let's say I've got a 5 mile an hour wind at 300, instead of holding the full 0.6 mils, now I can hold 0.3 mils because it's 5/10 or half or 1/2 if you're simplifying it of the wind hold that I would have to do normally. So that's why I like to use 10 mile an hour wind. If I have a 12 mile an hour wind, then I can just multiply it by 1.2, and then that's my wind hold. Alright, so now I'm going to talk about another unit of measure or both units of measure. So we've been talking about mil radians. I use mil radians because that's what I've used pretty much as long as I can remember. I've used it in the military, I've used it on the civilian side. It's familiar, it's convenient, but it's not really well suited for easy math whenever you're not using the metric system. In the United States, we think of things in inches, yards, feet. In other countries, you would think in kilometers, meters, centimeters. So now I'm going to explain the way that mils work in the metric system. So everywhere else in the world, why mils are awesome. So at 1,000 meters, 1 mil equals 1 meter, or 100 centimeters. At 100 meters, 1 mil equals 10 centimeters. So do you see how this could be a lot easier to just use tens and hundreds and whatever, and just moving a decimal place and adding zeros? That's really where mils shine. Unfortunately, I don't think that way. You know, this is America, and I think in inches, feet, and yards. But I've done it so much that I've become accustomed to it, and that's what I use. Now, there's another angular unit of measure that's a lot more popular here in the United States, and there's also a lot of common misconceptions about it, and we're going to talk about that right now. Minutes of angle. So I hear a lot of just the wrong thing whenever it comes to minute of angle, and it doesn't really bother me because it, shooter dependent, the level of precision for the rifle shooter and ammunition combination might not be able to achieve that level of precision. But we're going to talk about shooter minute of angle versus the actual unit of measure, minute of angle. Shooter minute of angle is something that we shooters have come up with that makes math a little bit easier. And what it equals out to is 1 inch at 100 yards, 2 inches at 200 yards, 3 inches at 300 yards. And it's just a lot easier to do it that way. Because you can just take your target size in inches, multiply it by 100, then divide it by your minutes of angle, and then you get your target size in yards. But you're giving a little, giving a little, giving a little, and that can equal a whole lot of miss downrange. Now, I'm going to talk about the actual unit of measure, minutes of angle. And what that is 1/60th of 1 degree. 1/60th of 1 degree actually equals 1.0472 inches at 100 yards, not 1 inch. Is it that big of a difference? Depends on how precise you want to be. But it does change your math also. So now instead of taking your target size in inches and multiplying it by 100 and then divide it by your minutes of angle, to get a more precise distance in yards to target, you would take your target size in inches, multiply it by 95.5, and then divide it by your minutes of angle, and it'll spit out your distance in yards. Alright, so now I'm going to talk about scope tracking error. Scope tracking error doesn't necessarily mean that your scope is bad or cheaply made or anything like that. It just means that there are tolerances in the machine. Tolerances cause variation, and there's nothing wrong with it. It just needs to be accounted for in your firing solution. The way that I do that is I put a target at 100 meters for my mil scopes, a target at 100 meters. I make my point of aim and point of impact on that target, a small target on there. I'll adjust my turret, my elevation turret, up 10 mils, and then I'll maintain that same point of aim. I'll fire 10 more shots, and hopefully, if I have a 0% scope tracking error, which is what you want, it will be 100 centimeters high from your original point of aim. And that is, optimal, is that you hit exactly 10 centimeters high, and it's perfectly in line with it as well. We'll talk about that also. There's a scope cant or weapon cant too, but we'll talk about that in another video. Actually, I did talk about it in another video. So anyway. Alright, so let's say that you don't get a perfect 100 centimeters. Let's say you get 95. Alright, so now you've got 95 centimeters. Well, does that mean I send my scope back? No. It means you account for it in your firing solution. So if your firing solution calls for this X, this is 100%. Well, you need to add an additional 5% to that so that you can make up for the lack that your scope has. So now instead of making a 10 mil adjustment, you would have to make a 10.5 so that you have that additional 5%. So you have to give it 105% of what it actually calls for to account for that scope tracking error in that case. Let's say it's over. So instead of 100 centimeters, it was 105. Well, now you would use 95% of your firing solution to account for that on whatever it might be. For minutes of angle, you set up your target at 95.5 or 95.5 yards, and then you fire a group. You can go up 30, or however many you want to do. 30 minutes of angle is what I use. And that should be 30 inches. That's why it's at 95.5 yards, not 100 yards, so that I can actually use inches. So it should be 30 inches. And then, same thing. You figure out what your error is, you divide those numbers into each other, and you account for it in your firing solution. I could sit here and talk for hours about all the factors that affect long-range shots or even short-range shots. But unfortunately, I don't think anybody would watch my YouTube video if it was 3 hours long, 4 hours long, 5 hours long. So if you have any more specific questions to ask about long-range shooting, You can shoot me a message on Facebook. My name is Cameron Hayes. Or you can shoot me a message on YouTube. I can't promise I'll get to it anytime soon because I don't really check my comments or anything like that on YouTube. I don't have like a laptop. I just do it on my cell phone. So hence my video quality is not that great. Go to Red Hill Tactical's website. Get you one of these awesome dope cards, DMR dope cards. Give them your information so they can put the right stuff on it. If you don't know what information to put on it, send me a message and ask. I'll tell you what information you should have put on it, or at least what I would have on it. I mean, different strokes for different folks. You're going to want something different than what I want. And like and subscribe to my YouTube channel. And Hey C494 out.